Good afternoon, class. We are already in the fourth week of our class. On our fourth week, our topic will be about operations on rational expression. These are our objectives for this week. Perform the operations of rational algebraic expressions and simplify complex fraction. So we have here our chart for the flow of our topic. Our main topic will be about operations on rational algebraic expressions, and its subtopic will be about multiplying rational expression, dividing, adding rational expression, subtraction or subtracting rational expressions, and then the last one is complex fraction. So under that subtopics, we have problem solving. Let's begin with multiplying and dividing rational expressions. Note the two different forms for denoting division. We will use either as needed to make sure you are familiar with both. Note as well that to do division of rational expressions, all that we need to do is multiply the numerator by the reciprocal of the denominator. Example, the fraction with the numerator and denominator switch. Before doing a couple of examples, there are a couple of special cases of division that we should take look at. In the general case above, both the numerator and the denominator of the rational expression are fractions. However, what if one of them isn't a fraction? So let's look at the following cases, because students like you often make mistakes with this initially. To correctly deal with this, we will turn the numerator, which is the first case, or denominator, the second case, into a fraction, and then do the general division on them. We have here the four cases. Let's begin with case 1. A over B multiplied by C over D. So if multiplying both fractions, this will be equal to AC over BD, or you're going to multiply A by C and then divide by B and D. Next case is A over B divided by C over D. So it is division of fraction. In division of fraction, the second case or the second term will be changed or with what we called the reciprocal. So the numerator will become the denominator, and then the denominator will be our numerator. And then if you already look for the reciprocal of the second term, you can now proceed to multiplication. So it will be A over B times D over C, or AD times BC. Our case number 3, A divided by C over D. So as we can see, our numerator is a whole number. Meanwhile, our denominator is a fraction. So first thing we have to do is we're going to transform or transpose to fraction. Our numerator we're going to put it into a fraction form. So what will happen? Just add or put 1 as our denominator. So what will happen? It will become a over 1 because any whole number has a denominator of 1. So a over 1 divided by c over d. Since we are going to divide it, for the next step we're going to do is find the reciprocal of our denominator. So since our denominator is c over d, its reciprocal will be d over c. And then if after that, multiply. So a over 1 times d over c is equal to ad times c. Our last case, a over b divided by c. So in this case, again, the denominator was the whole number. Same process with what we have in the case 3, just add or put 1 as the denominator of the number which is whole number. So after making it all as fraction, look for the reciprocal of the denominator and then proceed to multiplication. We have here some illustrative example. Number 1. Find the product of 5t divided by 8 and 4 divided by or 4 over 3t squared. When we say find the product, it means we are going to multiply. So 5t over 2 raised to 3 times 2 raised to 2 over 3t squared. So as we can observe, 8 becomes 2 raised to 3 and then 4 becomes 2 raised to 2. Why? So in multiplying and dividing fractions, we must have to express the numerators and denominators as prime factors as possible. Why? So that we can simplify much easier to solve. So since we have already simplified anything that can be simplified, 2 raised to 3 and 2 raised to 2. So what will happen? Multiply 5t times 2 raised to 2 and then over 2 raised to 3 times 3t squared. So if you can cancel something to make it simplest into its simplest forms, then we can. We have here 5t in our numerator and then at our denominator we have also same variable. So we can cancel it out. So what will happen? Cancelled out ang t sa 5. So mabilin is 5 na lang. So that 3t squared will become 3t. And then here, 2 raised to 2 over 2 raised to 3. So cancelled ang numerator and then since 3 man ang exponent sa denominator, na ay mabilin isa ka 2. So 5 over 2 times 3t. Okay, and then after that, simplify rational expression using laws of exponents. So 5 over 2 times 3t will be 60. So our final answer will be 5 over 60. Okay, example number 2. Multiply 4x over 3y and 3x squared y squared over 10. So same process, simplify each number into prime factors, or if we say prime, it can be only divisible by itself and 1. If you can simplify anything, then simplify it into its lowest term. So 4x, we can simplify it into 2 raised to 2 multiplied by x, and then over 3y times, since 3 is already a prime factor, then dili na nato siya hilabtan. Meanwhile, ang 10 is, we can simplify it pa. So, we have 2 times 5. And then, after that, is we're going to combine. 2 raised to 2 times x times 3, x squared times y squared over 3y times 2 times 5. So look for anything that can be cancelled out. If there's anything that be cancelled, then cancelled it. Just like here, we have the numerator 2 raised to 2, and then in the denominator we have also 2. So cancelled out siya, and then naay mabilin isa ka 2 sa numerator. And then 3 will be cancelled too. And then ang y, since x, wala man tay x sa denominator, so x cube will remain. And then kaning y squared, mahimo na lang siyang y, kaya naman say y sa denominator. So what will happen? It becomes 2 times x cubed times y over 5. So its simplest form, the final answer will be 2x cubed y over 5. Illustrative example number 3. What is the product of x minus 5 over 4x squared minus 9 and 4x squared plus 12x plus 9 over 2x squared minus 11x plus 5? So this example seems to be more complicated. We have here some questions on the right side. What factoring methods were used in this step, and then what is the rational algebraic expression equivalent to 1 in this step? So same as usual, we are going to simplify each term so that we can have our final answer. So x minus 5 remain lang siya since it is already simplified. And then this one, 4x squared minus 9. So we can simplify it. It becomes 2x minus 3 times 2x plus 3. And then our second fraction is 4x squared plus 12x plus 9. So it can be simplified into 2x plus 3 raised to 2. And then the denominator 2x squared minus 11x plus 5, we can also simplify it into 2x minus 1 times x plus 5. So after it, we're going to combine x minus 5, combine it into one fraction. X minus 5 times 2x plus 3 raised to 2 over 2x minus 3 times 2x plus 3 times 2x minus 1 times x minus 5. Same as usual. Cancelled anything that has the same variables. Just like here we have x minus 5, and then in the numerator, and then in the denominator we have also x minus 5, so we can cancel it out. And then we have also 2x plus 3 squared in the denominator, and then numerator rather, and then in the denominator we have also 2x plus 3, so cancelled out. And sa numerator, ang ma-remain lang is 2x plus 3 over 2x minus 3 times 2x minus 1 na lang. So after it, since we can still simplify it, so its final answer will be 2x plus 3 over 4x squared minus 8x plus 4. With division problem, it is very easy to mistakenly cancel something that shouldn't be cancelled, and so the first thing we do here before factoring is do the division. Once we've done the division, we have a multiplication problem and we factor as much as possible, cancel everything that can be cancelled, and finally do the multiplication. So here in the illustrative example number 4, it is a division problem. So no need to explain, just understand the problem, understand the process, and same with illustrative example number 5. So next is adding and subtracting rational expression. Simple process for finding the least common denominator for rational expression. Here is it. First, we have to factor all the denominator. Second, write down each factor that appears at least once in any of the denominator. Do not write down the power that is on each factor. Only write down the factor. And then, third, since each factor was already written in the previous step, next is you're going to write down the largest power that occurs in all the denominator containing that factor. The product of all the factors for the previous step is the least common denominator. A over B plus B over C. So it can be A plus B over C. And then here, A over C minus B over C. It can also be A minus B over C. Okay. Example number 6, addition. X squared minus 2x minus 7 over x squared minus 9 and 3x plus 1 over x squared minus 9. So we're going to add. Okay. So we are going to combine like terms in the numerator. And then factor out the numerator and the denominator. Another example is subtraction. The same process with the addition of fraction. Just combine the like terms in the numerator and then factor out each numerator and denominator. So here for this problem, there are coefficient on each term in the denominator. So we'll first need the least common denominator or the LCD for the coefficient. So now x by itself with a power of 1, it's the only factor that occur in any of the denominators. So the least common denominator will, for this part, is x with the largest power that occur on the x's in the problem, which is 5. So the least common denominator for this set of rational expression is 6x raised to 5. So that's all for our discussion. Just do your quiz and assignment. Thank you.